Morning. I hope that y'all are all having a great day and that you had a good weekend. And I hope that you have not tried that you have tried these questions and you're not just going to watch me talk through it. Instead of trying to write it out, I just decided to pull up the solutions scoring guides and just talk through it with you. And then if you've got any questions, then tomorrow when I'm back, we can definitely start with this. So number 2 is another calculator question, and you've got function f, you've got function g. Those are kind of complicated, so if you go to type those in your calculator, make sure that you are very careful with typing them in, because if you type them in wrong, your intersection points will be wrong, and everything else will get off. So first you're finding the sum of the areas. Well, the calculator will do the areas separately for you. Not a big deal as long as you have this intersection point. It'll also find that for you. So if you do second, calculate 5, then go to first curve, second curve, guess. It should give you that point. And what they've written down here, you don't have to be quite this precise. You do need to label it that you're looking for the intersection point there. That's where this point comes from, that you actually know what the limits are. Because you're going to have one integral from 0 to the intersection point, and then the other is the intersection point over to x equals 2. You can't find that intersection point without the calculator, so that's important. So you find the intersection point, you need the x. You don't have to have the y, but you do need the x because you're going to integrate in terms of those x's. So you also want to make sure you set up your integral. Now, Alex, like you've asked before, you can actually write out the function if you want to. Those are kind of long, but you can write out x to the 4th minus blah, 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 minus 1 plus x plus e to the x squared minus 2x, and then write them again over here, or just use g and f. There's not really a point in writing them out if the calculator is going to do the work for you, but you can if you want to. Again, you can write the limits out. They've written an A here where they've labeled it up above it, but you can write out 1.033. They've written out all the values, but at least 3 decimal places is required. And since this isn't the final answer, you might want to write out as many decimal places as you are given on the calculator screen. That will keep you from making a rounding error. So there are your limits. You've got a top curve minus bottom curve plus the other top curve minus bottom curve because your curves change. Here's the function f. That's the function g. Get the values, add them together. You just got 4 points. Easy as that. For part B, you're looking for volume, but it's with a cross-section that's perpendicular to the x-axis as squares. So perpendicular means you're going to be going from that top line down to that curve because you're just caring about region S. Now to find the volume, we need to integrate the area of the shape that you were given, and you were given a square. So the area of a square is side times side, and this side of the square that's coming up off this region, if you need a reminder of what that looks like, they're over on my wall, but you're going to draw that square from the top curve down to the bottom curve. Draw that square, the side of the square, top curve down to the bottom curve. And so that's why you've got f of x minus g of x down here. And you square it, because to find the area of a square, you would square the side length. And you can integrate just from that intersection point, so from A on the answer key up to 2. Let the calculator do the hard part. You've got 1.283. 3.7 points right there. That's really just calculator work if you write it down correctly. Then for C, you're finding h is the distance between f and g in this region. Find the rate at which h is changing. So the rate is the derivative. So you have to define h as f minus g. So you define h by what you were given. Then you say, well, I'm going to have to find the derivative. I get that from the word rate. So h prime is going to equal the two functions separately with their derivative and subtracted. But you just care about how it's changing at 1.8. So you can plug your 1.8s in, and if you've already graphed f and you've already graphed h, you can find the derivative at 1.8 and the value of the derivative at 1.8 in g. That's second, calculate 6. Get those two values, subtract them, and it will give you negative 3.812. And like this is what I was talking about on Friday. Even if you round incorrectly, you can still get the points for that answer. So that's question 2. Pretty straightforward. The calculator does the hard part for you. You just have to know how to write it down so that it can actually be set up. Okay, and then moving on to question 4. This is no calculator and it's a differential equation. There's your slope field. Hopefully those are getting easier. This one's pretty straightforward. There's no division. Those always stress me out. But that one's pretty easy. Then you're going to find the second derivative. So you have to take the derivative of 2x minus y. So 2 minus, now, well, we talked about finding the derivative of y, but we're finding the derivative of y with respect to x. So that's dy dx. Here's my second derivative. That's where the 2's are coming from. Equals 2 minus dy dx. And we don't want to throw in another variable, so we take this dy dx and replace it, sorry about that, with this 2x minus y. So your second derivative is 2 minus 2x plus y when you distribute your negative. And you're trying to determine concavity. Well, that's why we had to find the second derivative, because concavity is determined off of it. So if you think about the second quadrant, x's are negative, y's are positive. So if we do 2 minus 2 times the negative, well, negative 2 times the negative is going to be a positive. So 2 plus a number plus another number, well, that's going to be greater than 0. So every value in the second quadrant is going to be concave up, because based off of the second derivative that I found and knowing what we know about the second quadrant, I'm always going to be positive. Okay, C, we got a particular solution, or let y be the particular solution. You're given this condition. Your x value is 2, your y value is 3. Does f have a minimum and maximum, or neither at x equals 2? Well, minimums and maximums are where the derivative equals 0. So if we go back to that's what this is considering. You don't have to necessarily write that out. It says it over here, but you have to show that you plugged x and y into the derivative somehow. So you've got to make that very clear that you knew to go back to that original derivative you were given. You didn't try to plug it into the second derivative. So if you plug in your x and your y, you get 1. Well, that does not equal 0. The only time we have maximums and minimums are if the derivative equals 0. So since it's not equal to 0, no minimum, no maximum. Now D, we haven't worked any like this before, and it's a little complicated, so if we need to start here tomorrow, we can. But find the values of the constants m and b for which y equals mx plus b is a solution to the differential equation. And so you've got to figure out, what would I need to do to this to make it look like that? Well, this is a regular function. That's a derivative. So you have to take the derivative of this regular function to figure out how does it relate to this derivative that I was given. That's what this first line is saying. You're going to take the derivative of both sides. Well, the derivative of y is dy dx. And then you're taking the derivative of this entire side, d dx, of mx plus b. But when you take the derivative of that, x goes to 1. B is a constant, so the derivative of b is 0, and you're just left with m. So that's what this line is saying. Well, m is equal to the derivative. So we can take that m and set it equal to the derivative that we were given, 2x minus y. We can take our y and plug back in mx plus b. We're trying to get rid of some variables here. And then this third line is some rearranging, getting fancy. So if you take out your x, they put it at the back, so we normally put it at the front, but it's fine. 2 minus m times x minus m plus b equals 0. So you factored out this x and factored out this x. And took this m and moved it over so that we were equal to 0. And then you know that in order for this to equal 0, this value would have to equal 0. That's the only way to get this x to go away. So 2 minus m has to equal 0, which means m equals 2. Also, m plus b would have to equal 0. You have to have a 0 here and a 0 here. So if that's the case, then b equals negative m. Then m equals 2, b equals negative 2. So 2 and negative 2. We can revisit that tomorrow if we need to. We also need to revisit number 1C, I think. So I hope that helped. I hope that you've gotten lots of multiple choice questions done today. If you got time tonight, look at 5 and 6 so that we can look at those tomorrow in class. I'll see y'all later.